Session 1.5 Applications and Modeling with Quadratic Equations. Let's look at this example. We want to solving a problem involving the volume of a box. Okay, volume of a box. A box with volume 7,500 centimeters cubed is to be formed from a sheet of metal whose length is twice the width. Okay, whose the length is twice the width. Equal size square measuring 10 centimeters on a side are to be cut from the corners of the metal sheet in order to form the box. What are the dimensions of the original piece of the metal? So first, we're gonna let x be the width of the original rectangle. Okay, and then based on this information here, formed from a sheet of metal whose length is twice the width. Okay, twice the width. If we let the x be the width of the original rectangle, how can you let the length in here? Okay, twice the width. So we're gonna let 2x be the length of the original rectangle. Okay, because of this one. The length is twice the width. Now we try to sketch the picture here. So this is going to be my width, which is going to be x, and the length is going to be 2x. Okay, equal size squares measuring 10 centimeters on a side are to be cut from the corners of the metal sheet in order to form the box. So you could see we're going to cut out the square from each corner. And then we have the dimension. This is going to be 10 centimeter, 10 centimeter. So we could calculate what is the length of the box. Okay, the length of the box is talking about this line here, the length of the box. So the original rectangle here is going to be 2x. 2x minus 10 minus 10, that will be the length of the box. Okay, so that's why we have a 2x minus 20 here. Okay, and then same idea for the width here. The width of the box is going to be the x minus 10 minus 10, which is going to be x minus 20. So we let x minus 20 be the width of the bottom of the box. And then we also let the 2x minus 20, the length of the bottom of the box. Okay, so we have this picture. This is the width talking about here. This is the length talking about here. Okay, 2x minus 20. And then the height is going to be 10 centimeters. Okay, because of this. Okay, now we still didn't use one of the information, the box with the volume 7,500 centimeters, right? So what is the formula for the volume of the box? That will be the length times the width times the height. Okay, length times the width times the height. And then we're gonna plug it in. The length is gonna be 2x minus 20 times the width, x minus 20, and then times the height, that will be the 10, plug it in, equal to 7,500. Okay, I want you guys to distribute one by one. So you should get this guy, all right? And then let's combine the constant together. Write it in the standard form. We subtract 7,500 for both sides. So you got get this guy. Simplify a little bit, okay? We could divide it by 20 for the whole equation. Use the x method to simplify it. You should get two factors, x plus 5 and x minus 35. Use the zero product property. X plus 5 equal to 0 or x minus 35 equal to 0. So x equal to negative 5 and x equal to 35. So is it possible that the axis represent the length and the width, right? Can it be negative? No, right? So we're gonna reject this answer. Okay, the distance or the length has to be positive. So what they're looking for, what are the dimensions of the original pieces of the metal? So we want to plug in back x is equal to 35, and then the length is going to be 2 times x, which is 2 times 35. That will be 70. Okay, make sure you guys answer the question and stay with the unit. Okay, using the Pythagorean theorem, this is going to be white triangle. Okay, we do have a 90 degrees. And then we do have a called leg A, leg B. Okay, and then the longest side, the side opposite to the 90 degree, we're gonna call this as the hypotenuse. Okay, one more time. Hypotenuse, the longest side, is always opposite to the 90 degree. And then we have the formula. A squared plus B squared equal to C squared. A and B here, you could switch it, doesn't matter. But for the C, the longest side is always equal to C squared, equal to the hypotenuse square. Okay, let's try one example. A piece of property is in the shape of white triangle. The longer leg is 10 meters, shorter than the twice the length of the shorter leg. And the hypotenuse is 20 meters longer than the longer leg. Find the length of the side of the property. So first, we're gonna let x be the length of the shorter leg. We try to let x be the length of the shorter leg. We don't let it for the longer leg because the given information here. The longer leg, that is based on your shorter leg. So we're gonna let x be the shorter leg first, and then we'll plug in the x here. So think about it. How can you guys let the longer leg based on the x in here? So this one's longer leg is 10 meters shorter than twice the length of the shorter leg. Okay, so that'll be the 2x, and then it's 10 meters shorter than, so 2x minus 10 will be the length of longer leg. Okay, now how about the hypotenuse? The hypotenuse is 20 meters longer than the longer leg. Okay, 20 meters longer. So 20 meters plus 2x minus 10. So combine the 9 terms, so that'll be 2x plus 10. So now we do have all the information. We're gonna put it to the white triangle here. Okay, the x, the shorter leg, the longer leg, and then the hypotenuse. And then we're gonna apply the formula, the Pythagorean theorem. So a squared plus b squared equal to c squared. Plug it in. Okay, this one I want you guys distribute by yourself. 2x minus 10 times 2x minus 10. Or you can use the formula, a minus b squared formula. You should get this guy. And then combine the 9 terms. Okay, I only have the x squared minus 80x equal to 0. Okay, you don't want to divide it by x for the whole equation. We don't want to divide a variable. Instead of divided a variable, we want to factor out the x. Okay, factor out the x. So you do have a two answer. One is x equal to 0. One is x minus 80 equal to 0, which is x equal to 80. And then think about it. Can x equal to 0? X equal to 0 in here, that will become negative. Can the length of the triangle be the negative? No, right? So we're gonna reject this guy. So we only have x equal to 80. So they want to find the length of the size of the property. So we're gonna plug in back. Shorter leg here, that'll be equal to 80. The longer leg, we're gonna plug it in. So that will be 150 meter. And then the hypotenuse, plug in x equal to 80 here, you're gonna get 170 meter. Okay, next one. Height of a projected object. If air resistance is negated, the height s in feet of an object projected directly upward from the initial height of s0 feet with initial velocity feet per second is given by the equation. So we do have the equation here. S represent like the height of the object. So I could have an object here. This is the height. Okay, this is going to be S. When we project upward, we do have an initial height of S0. Let's say my initial S0 is going to be here with the initial velocity. So we're going to poke like this. Okay, when they go up, this is the initial velocity. And then we do have the equation here. And then the t represent the number of the seconds after the object is projected. So we're going to count from here. When my project my object, they do have the time, right? That's the t. And this is gonna be in number of the second. Okay, and then the negative 16 is just a constant speed based on the gravitational force of the earth. We know that we do have a gravitational force from the earth, right? They're gonna going down for sure. Okay, let's try an example. If a projectile is shot upward from the ground with an initial velocity of 73.5 meters per second, negating air resistance, its height moved the ground t seconds after the projection is given by. We do have the equation to represent this problem here. And then A, after how many seconds will the projectile be 100 meters above the ground? So 100 meters, this is talking about the height of the object. Okay, I want to know, find out the t when the projectile will be 100 meters. So we're gonna plug into this equation, s equal to 100 meters. And we want to find out what is your time, what is your t. Okay, what's in the standard form. And then I want you guys use the quadratic formula to solve this equation. Okay, plug it in. A equal to 4.9, B equal to negative 73.5, C is gonna be equal to 100. Use your calculator. You should get 1.51 or 13.49. Okay, this is talking about the time. Does it make sense to you guys? How come we do have a two answer here? Both solutions are acceptable since the projectile reached 100 meter twice. Okay, so it means like, okay, I'm gonna project it from here. Okay, when I shot it upward, go upward, and then we hit the 100 meter. And then later on, when they go back, come back here. They're gonna meet the 100 meter again, and then they're gonna fall. Okay, so you do have a 2t here. Okay, how long will it take for the projectile to return to the ground? So we're gonna shit here, and then we're gonna go back and then hit the ground again. So think about it. We want to find out the t when s is equal to the projectile go back to the ground. So the s is gonna be equal to 0. Okay, plug into this equation. Factor out the t. You should have a two answer. One is a t equal to 0, or solve this equation. We're gonna add 4.9t for both sides. divided by 4.9. So you're gonna get 15 seconds. So 1 is when we start shot the projectile, t equal to 0. Okay, and then when it go up and then go back, hit the ground, the t is gonna be 15 seconds. Okay, make sure you answer the question. That's it.